Okay, our last section, problems that will involve some trig. I saved the toughest parts for the end, but we're going to be okay. We'll be okay. Take a moment, read through number 14, Edpuzzle will pause. Well, let's see if we can draw a picture here. Let's see. So, a plane is flying west. Here's my plane. Wow, that's really not good. But it's a plane. You know it's a plane. I've got a searchlight on the ground that is kind of tracking my plane. And here's the distance over there. I can make a right triangle out of this. The plane is at an altitude of 4,000 feet, so I'm going to go fill in my 4,000 feet over there. The plane is flying west at 500 feet per second. That's how I'm changing this side of my triangle. So I'll fill that in. Actually, why don't I fill that in right now? I know that dx dt is going to equal, well, given where I drew my plane, if it's flying west, I'm shrinking that side. So I'm going to make that negative 500 feet per second. You could have also drawn the plane like over here, in which case, if it was flying west, you'd be increasing that side. That's totally fine. It will work out the same in the end. But what I want to deal with is the change in the angle of elevation. I want to find, part 2, I want to find d theta dt, the rate of change of that angle. In particular, when the plane is 2,000 feet away, when x equals 2,000. There's a lot to kind of unpack here. First of all, I wasn't told any information about the hypotenuse, but actually, it's not going to matter. All that I need is some way to relate my angle, my 4,000 that's not changing, and my side over here that is changing that I was told information about. Think right triangle trig. I've got my theta here. 4,000 x. What can I use to relate them? A sine? A cosine? A tangent? Something else? What do you think? I can say that the tangent of theta equals 4,000 over x. That's going to be the formula that I work with. The tangent of theta equals 4,000 over x. That's the formula that I'm going to use, relating a side that's not changing with a side that is changing. Okay, well, before we move on, this is actually going to be a little bit easier if I write it as the tangent of theta equals 4,000 x to the negative 1, so then I wouldn't have to use quotient rule. I'm going to go and do my derivative. The derivative of the tangent of theta, well, the derivative of tangent is secant squared, so I'm going to say secant squared theta. However, remember that everything's a function of time, so not just secant squared theta, but secant squared theta d theta dt equals. I'm going to do the derivative on that side, and I'm going to get negative 4,000 x to the negative 2, but don't forget when you're done with that, a dx dt. I'm going to do a little bit of rewriting, I suppose. Secant squared theta d theta dt equals negative 4,000 over x squared times dx dt. Why don't I plug in while I'm at it? And I can say secant squared theta d theta dt equals, oh, we're going to get a lot of zeros here. 1, 2, 3, 4, 5, 6. You're going to get 2 million, I believe, over x squared. Now I need to plug in. Problem is I don't know theta. But you know what? I actually don't care about theta. I care about the secant of theta. So there's a trick I'm going to use. At my specific instance, I have a triangle that looks like this. There's my theta. I know this is 4,000, and I know that at my specific instance, this is 2,000. Go find the hypotenuse. Go use Pythagorean theorem. Find the hypotenuse. I'll make Edpuzzle pause. When you go to do your Pythagorean theorem, you should get the square root of, let's see, oh, this is looking like 20 million. Sorry for the big numbers. When we're dealing with airplanes, though, we have to have big numbers here. The secant of theta is my hypotenuse over my adjacent. My hypotenuse is the square root of 20 million. My adjacent is 2,000. You know what, though? It's going to be even better than this. I don't care about secant of theta. I care about secant squared of theta. So go square both of those. You're going to get 20 million. Yeah, I know it's a pain, but it'll get better. Over 4 million. So really, the secant of theta is just 5. That's it. I'm now going to plug in. The secant squared of theta, that's 5. 5 d theta dt equals 2 million over 2,000 squared. 5 d theta dt equals, well, 2,000 squared, that's 4 million. 2 million over 4 million is going to give me a half. And then we'll get d theta dt equals 1/10. Now, the units. D theta dt. The units for theta, I didn't tell you that in the problem, but theta is an angle. In calculus, how do we always measure angles? I feel like I've mentioned this a few times. In what units? We measure angles in radians. So this is going to be 1/10 radian per second. We're going to do one more of these. Take a moment, read number 15, and see if you can draw a picture for number 15. Actually, see if you can draw a picture and set up your parts 1 and 2. Another ladder. Wonderful. Here's my wall. Here's my base. Here's my ladder. Ladder's 50 feet. That's not changing. We're told how the base is changing. I'm going to make my base x. And if the base is getting pulled out, I know that dx dt is 25. No, it's not. Actually, I don't know anything about that. Sorry. I should be going on to part 2. I want to find the rate that it's being pulled out. I want to find dx dt. In particular, when x equals 25 feet. The angle between the ladder and the wall, I think that's going to be this angle over there. I know d theta dt is 1/4 radians per second. Find the rate. Okay, so I need to relate this angle with this side with this side. Let's see, I've got an opposite, I've got a hypotenuse, that's a sine. Sine of theta equals x over 50. Or I can even say sine theta equals 1/50th times x. Go do your derivative. Edpuzzle's going to pause. Derivative of sine theta is cosine theta, but don't forget your d theta dt. Oh, this is going to be really nice now. Derivative of 1/50th x is 1/50th dx dt. Might as well plug in my 1/4, and I'm going to get cosine theta times 1/4 equals 1/50th dx dt. Dealing with our specific instant now. There's my theta. That's 50. This is 25 for my specific instant. Go use your Pythagorean theorem, find the missing side, and then let's get a cosine of theta. And let's give exact answers with roots in there. Getting square root of 1875 over there. So the cosine is square root of 1875 over the hypotenuse, which is 50. I'm going to say square root of 1875 over 50 times 1/4 equals 1/50th dx dt. Multiply both sides by 50. We're going to get square root of 1875 over 4 equals dx dt. I might as well just leave it like that. And the units are going to be feet per second because it was the rate of change of that side. And this is all I have to say about related rates. This packet is all the variations you're going to have to be able to deal with when we get to a test on this stuff.